China just created a sun inside a building, not the one in the sky, a man-made one, burning 6 times hotter than the core of our own sun. And the part that should stop you? They can control it. For 70 years, the United States, Europe, and Japan have been chasing this exact breakthrough. Trillions of dollars, decades of research, thousands of scientists, and then China walked into a lab in one city, flipped a switch, and held an artificial star burning for nearly 18 minutes straight. That's not catching up, that's jumping ahead. The machine is called EAST, Experimental Advanced Superconducting Tokamak. From the outside, it looks like a giant metal drum wrapped in cables and pipes. Nothing about it looks special. But inside, something unbelievable is happening. They are creating a miniature star and trapping it using magnetic fields. On January 20th, 2025, EAST sustained plasma for 17 minutes and 46 seconds at over 100 million degrees Celsius. To put that into perspective, the surface of the sun is about 5,500 degrees. The core, where fusion actually happens, reaches around 15 million degrees. EAST was running at 100 million inside a building, and it didn't collapse, it didn't fail, it held. That single number changes everything, because this isn't just about breaking a record. It's about solving one of the hardest problems in human history: fusion energy. Right now, almost all of our energy comes from burning things: coal, gas, oil. We create heat, boil water, and spin turbines. It's a system we've used for over a century. Even nuclear power today works by splitting atoms apart. That's called fission. It produces huge amounts of energy, but also dangerous radioactive waste that lasts thousands of years. Fusion is completely different. Instead of splitting atoms, you force them together. You take hydrogen isotopes, heat them until they become plasma, and push them so hard that they fuse. And when they do, they release massive amounts of energy. Here's the number that matters. 1 kilogram of fusion fuel produces as much energy as 10 million kilograms of coal. And that fuel? It comes from seawater. Not rare, not limited, not controlled by any country. It's everywhere. No carbon emissions, no long-term nuclear waste, no meltdown risk. Because if anything goes wrong, the reaction just stops instantly. This technology has been the dream: unlimited clean energy. But there's a problem, a brutal one. To make fusion work, you need temperatures so extreme that nothing on Earth can touch it. Not steel, not ceramic, nothing. At 100 million degrees, everything instantly vaporizes. So how do you contain something that hot? You don't. You suspend it. A tokamak uses powerful magnetic fields to hold plasma in midair. It never touches the walls. It floats, controlled entirely by magnetic force. That's what EAST does. And here's where it becomes almost impossible to comprehend. Inside the reactor, the plasma is hotter than the sun's core, but the magnets surrounding it are kept near absolute zero, the coldest temperature possible. Both extremes exist at the same time, just meters apart. The temperature difference inside that machine is greater than the difference between the sun and outer space. And China held that balance for nearly 18 minutes. That's not just impressive, that's historic. And they didn't get there by accident. In 2021, EAST held plasma for 100 seconds. In 2023, it reached 403 seconds. In 2025, it hit 1,066 seconds. That's not steady progress. That's acceleration. They nearly tripled their own record in a single run. And then in 2026, something even more important happened. Chinese scientists pushed plasma density beyond what many physicists believed was a hard limit, a point where the system should become unstable and collapse. But it didn't. It held. That's not just breaking records. That's rewriting the rules. And this is where the story changes from science to strategy. China isn't building east just to experiment. This is step one of a long-term plan. The next machine is already in development. It's called BEST, and it's expected to reach first plasma in 2027. Not decades from now, less than 2 years. After that comes CFETR, a full-scale fusion power plant test reactor designed to generate actual electricity, not theory, real output. Hundreds of megawatts in the 2030s, scaling toward gigawatt levels after that. Now compare that to the rest of the world. ITER, the massive international fusion project in France, involves over 30 countries. It's been under construction for years. Costs have exploded past 20 billion euros. And its timeline? First plasma is now expected around 2035. And even then, it won't produce electricity. It's purely experimental. China is running experiments now, building the next reactor for 2027 and planning full-scale energy production while others are still trying to prove it works. That gap matters. Because fusion isn't just an energy breakthrough, it's a geopolitical one. Right now, global power depends on resources, oil fields, gas pipelines, shipping routes. Entire economies are shaped by who controls energy. Fusion removes all of that. The fuel comes from seawater. No country owns it. No one can block it. No one can control access. The first country to make fusion work at scale becomes energy independent in a way the world has never seen before. No leverage, no dependency, no supply risk. That changes everything, and China knows it. This isn't random progress. It's coordinated, funded, accelerating. Every milestone is part of a larger plan. Human civilization has always been powered by fire, from the first campfires to coal plants to gas turbines. We burn things to survive. Fusion ends that. No burning, no emissions, no depletion, just energy, pulled from the same process that powers the stars, enough to power humanity for millions of years. And the country that perfects it first doesn't just lead the future, it defines it. China didn't just build a machine, they built a star. And for the first time in history, it's one we can control. Which part surprised you most? The temperatures, the timeline, or how close this actually is? Let me know in the comments. And if you want more stories like this, subscribe.